All right, in this video, we're gonna use this AI automation to go from a still frame e-commerce product page like these Bose headphones and turn them into a beautiful motion graphics video that can be embedded on the website to capture this type of effect, where it features the product spinning on axis, showing exactly the 3D feel of the product. So now that we've seen the before and after output, let's run through a quick high-level demo of this automation in action, and then we'll get into a node-by-node breakdown explaining the build. So all we're gonna do to start is copy paste this product page into the n8n automation, and that'll kick off the workflow. And we'll start by scraping the product page that we just passed through to snag the image featured on that product page. This will then go into this generate image canvas workflow, which will take the image, send it to Nano Banana, and essentially prompt it to say, hey, we want 4 images of this product rotated 90 degrees every time. And we're adding this step to enhance the product fidelity of the final video generation that gets created. So we can check out the set canvas result here. We'll dump to Google Drive, and we can see that it is generated there nicely of kind of those turned views of the product just from a single input image. Then we're going to break out each individual image from the canvas with this prompt, which will essentially say, extract all of the 2x2 collage containing 4 separate product photos. And so we'll snag individual photos for each and ultimately pass those into the video generation model, which we're using Veo 3.1. So with this row, we've extracted individual images from kind of the original canvas that we generated. So now we have individual images of all of the angles of the headphones. And you can see those, for example, here, etc. And we've done this generation multiple times. And then we will pass all of those images into this generate video node, which we can see we're making use of Veo 3.1's ingredients feature, which will allow us to pass in our prompt, which is saying, create a smooth, seamless product showcase video. Please pay close attention to product dimensions, etc., etc. So make this video, and then based on all of these reference images that we're passing through that we just generated. So the goal here is to use these images to make the motion graphics video much more accurate and with higher product fidelity. Then lastly, once Veo 3.1 has generated the video, it'll dump the final output into Google Drive. So I have just downloaded the video that it generated, and let's take a look at that. So pretty awesome. And then we can use that on our website to provide a beautiful motion graphics feature of the product doing a nice 360 on a pure white background. All right, if you want to download this exact automation that we built and tailor it for your use case, you can snag it completely for free in our AI Automation Mastery School community. You can join for free. Then you'll go to the n8n templates section, navigate to the automation that you want to download, and then the JSON will be right here for you to download, and you can pull that into your n8n. And lastly, if you don't want to mess with n8n to create awesome product videos like this, you can generate these types of product videos automatically and many other thousands of high converting ads with our platform, Fabric AI. Our team here at The Recap is building this AI ad generation platform, and it's going to be awesome. It's launching here in the next couple of weeks. So join the launch list for Fabric AI. It's going to be sweet, and we would love to have you test the product before we launch it all the way out to the public. So drop your email to the launch list and we'll be in touch. Now, with that, we're going to go into the node by node breakdown of this workflow, show you exactly how we thought about building it with Lucas.
All right, I want to get started here with a brief system overview of this n8n automation we're going to be building before going through it node by node. Really important for you guys to understand the high level flow of how data is going to move through the system and the approach we've taken to kind of stitch all these prompts together. So let's dive right into it. I've split this up into really 3 separate sections. One is going to be generating the product canvas that corresponds to the first row up here. 2 is going to be extracting and upscaling our HD product shots from our product canvas. And so if I pull up one of these here in Google Drive, we need to grab each of these pieces independently and upscale them to a HD image. And 3, we're finally going to take those individual product reference images, pass it off to VO 3.1, and generate our final product video. So let's zoom in just a little bit to each of these before we go through the node by node breakdown. So going back to this first road here in the product canvas we're trying to generate, which is a grid that looks just like this, the first thing we're going to be doing here is going ahead and taking in a URL of our products page from any website or e-commerce site on the internet and start scraping that for the main image. For this demo, we grabbed this headphones image from this Bose headphones listing page, and that's perfect for our use case. And so we're going to make use of Firecrawl in order for that to happen. So we scrape that page, get that image extracted from the website, download that image, and then we're going to go ahead and pass that image off to Nano Banana Pro to actually build out our rotations all on a single output image, just like what we see here. You may be asking why we're doing it this way by building out this product canvas, and this is something that I actually hit into a roadblock while building out this system. You could, of course, generate 4 separate images trying to rotate it precisely, but I had issues actually getting those rotations to work consistently across a large variety of products. So instead, we're going to build a canvas like this, kind of extract each of these images one by one, blow them up, and work forward from there. So that's what I found to be the easiest way to approach this problem. As the models change, that may be different, but that's what works for me. Let's go on to number 2 here, which is going to be extracting and upscaling each of these product shots into an HD image. And so that's going to be all the logic that we have here on our second row, where we go from that single canvas image, and we're going to start blowing up and upscaling each of these images here. So we have some HD output like this for each of those angles we need. Pretty simple to approach this. It's really powered by just this extract prompt that I wrote that knows how to look at a single quadrant of this grid of our canvas that we made and goes ahead and tells Nano Banana Pro to analyze that, scale that up accordingly, and give us a much higher definition output. The final thing to cover here is going to be the logic where we pass off each of those upscaled reference images off to VO 3.1 to generate our final product video. If you remember from David's demo, we're trying to make a simple animation where we rotate this product around, showing all angles, and that's exactly what we're going to do here. We're going to build out a prompt that mentions 3 separate product reference images because that's what VO 3.1 supports right now, just up to 3 reference images. We're going to pass that prompt in. We're going to pass those reference images in to VO 3.1's API, and we're going to have it generate a video for us. So that request is going to get sent off, and then here toward the end, we're going to pull that API until we get that generation result back and finally save that to Google Drive. By the end of this, when all of this runs, we have all of our output images here, including our canvas, along with our final output video that shows it being rotated 360 degrees for our e-commerce product listing page. So now that we've gone through the system overview, let's go ahead and actually jump into n8n to go through the nodes used to build out our product canvas. I'm going to come over here, and the first thing we're going to see is our form trigger we have set up that's going to take in our inputs necessary. I'll pull this up, and we'll see that we have a single text element input for the product URL we're going to scrape and extract the main product listing image from. I'm going to pull this up, and we're going to see that we actually have that same URL here that we used in the demo for this pair of Bose headphones. So let's go ahead and run that now again so we can see data flowing through the entire system. So we'll kick that off. We'll see that we get that URL still extracted here as input, and everything's up and running. The first node we have here that runs is actually going to be one of the built-in community nodes maintained by Firecrawl. So if I search Firecrawl here on our node section, we can see that we have a ton of different operations available here related to scraping and extracting data from websites. So we're going to be using the scrape a URL and get its content operation. And so if I pull this up, we can see that exact same logic in here. We have our Firecrawl credential connected, which is very simple to set up. If you haven't done this before, just click create a new credential, go to the firecrawl.dev dashboard, create an account, and paste in your API key right there. That's all you need to do to authenticate any requests you're making. Then, once we go forward here, underneath this operation, there's a couple of different inputs we have to provide in order to get this working and actually extract that main image URL that we're looking for. So that's going to be this image here that has the full product view of our headphones. The first required input is going to be a URL that we have to pass in. So what we're going to do is grab that JSON and then grab the product URL value here from the input into this whole automation to get started. And so we can see since we have this as an expression, that's going to get dynamically slotted in right there. The next thing we have to specify is going to be underneath this scrape options section. Firecrawl has this really interesting feature called extract that allows you to write custom prompts to extract specific data from whatever web page you're scraping. Since, Firecrawl, their built-in features don't let you just grab the main product image URL from the page, we're going to have to build that out ourselves. And so we're going to set formats to type JSON, and then we're going to build out a prompt here to extract that main image. So very, very simple. Please extract the absolute URL of the main product image that is on this product listing e-commerce page. Basically, we're trying to mimic what a human would do if we come here and right click and then click copy image address. We're trying to let Firecrawl do that for us. The other required part of this is going to be giving Firecrawl a schema of the structured data we're trying to extract from that website. And so this is a very simple schema we have set up here. We set type to string and then give it a description of what we're trying to extract. And so this is just where I reiterate that same information in order to make this automation more reliable. So this is going to be the main product image URL extracted from this e-commerce product page. Exact same information. So everything I covered here is actually documented underneath this scrape endpoint here on the Firecrawl docs. So if you're looking for a bit more of an advanced use case, or you're trying to extract more complex data like an array of images, just search for extract on this page, and then you're going to be able to see how you can approach that. And so extract with structured data, and they have an example here of a more complex schema getting passed in. So be sure to check that out if you have a more complex scraping use case. But for now, we can continue forward. Just make sure you have only main content toggled on. That's going to make it a little bit easier to run and more reliable. And then I'm going to leave everything else here as default, no other changes. So if I pull this up, we can see we're getting a lot of data that comes back. There's really one main thing we're interested here in the response, and that's going to be underneath data.json. That's going to be this URL we're asking for of the main product image. So I'll pull that up in a new tab, and we can see we have this image matches this image exactly how we want it. So that's a great first step, and we're good to continue forward. The next thing I'm going to do is a simple HTTP request, so we can go from that URL to an actual image we can view here inside of n8n. And so we're going to grab that binary file we can work with and manipulate and reference for later. And then I'm going to convert this into a base 64 string just to make it a bit easier to work with the Gemini, VO, and Nano Banana APIs all together. What we're doing here is going to be using one of the built-in file nodes inside n8n where we extract from a file. Basically, we're getting that binary file we downloaded from before, and we're going to convert that into JSON data we're going to be able to process more easily and is actually required by those APIs I mentioned by Google Gemini. So it's that node, and we're going to use move file to a base 64 string. So we take this data and convert it into this data. That's all you need to do for here, and we can continue forward. The next step, if you recall, is going to be actually building out our prompt to go ahead and create this single canvas image like what we have showcased here on this grid of all of the different product angles. I like to do this inside a set field node just to keep my prompts clean from the nodes that are actually executing those prompts. And so if I pull this up, we can see we just have this prompt field set right here. And if I blow this up, we have this prompt that breaks down all of the different angles and transformations we want to make of the main product image we're passing in. And so we're going to take this image, we're going to take this prompt, and we're going to send it off to Nano Banana to build a canvas that looks just like this. Just at a high level, you will receive an uploaded product image. Generate 4 realistic images of the same product, maintaining perfect consistency in shape, proportions, color, textures, reflections, and label design. Only change the rotation angle. Please pick rotation angle and rotation axis that is going to present our product provided the absolute best on an e-commerce product listing page. The final resulting image you generate will be on a 2x2 grid, just like what we have featured right here. And then we expand a little bit more into some of the rules and other constraints we want to apply. But that's the gist of it here for generating our image transformations into that canvas. Next is going to be our HTTP request we're making off into Google Gemini's APIs, and more specifically, the Nano Banana image model. And so this is going to be called here into the Gemini's APIs website, but at the very end, in order to use Nano Banana Pro, we have to specify Gemini 3 Pro Image Preview generate content. That's the main endpoint necessary under Gemini's APIs to actually use Nano Banana Pro. I have authentication already set up here just by simply going to Google AI Studio. So if you search for that, you're going to be able to come up here, and then click create an API key, and that's going to guide you through the steps on how to actually add the authentication you need using header auth to connect n8n to the Google Gemini's APIs. I won't go through that for right now, but that's the high level overview of how to get that set up. The next thing that's going to be required here is actually building out our request body. So toggle on send body, set your body content type to JSON, and then under specify body, using JSON, and then you're going to be able to see this expression field here that we're going to build out. So this request is getting sent off to Gemini, and it requires two main parts here under this contents and parts array. Text is going to be the text prompt we're sending to Nano Banana, and so we're going to do a simple JSON.stringify to pass that whole prompt in that we covered from before. And then in order to pass our image off of our Bose headphones we see here, the next thing we have to do is pass in some inline data that's going to be an image. So I'll give it a MIME type. Basically, what's the file type of this image? I'm going to just mention it. It's a PNG. And then for data, we have to reference our node from before where we converted that n8n binary file into a base 64 string. So we just reference our node here, use json.data. Let's go ahead and grab out all of that data that references our product image. So that looks good. We're going to get our generation started. And then I'm going to use another set field node here to go ahead and extract the image part of the response we get back from Gemini. If I pull this off to the side, you can see there's a lot of it's kind of a complex shape of the data we get back. This is a simple expression you can just borrow and copy paste if you download this template to go ahead and get that data back that you need. That way you don't have any errors or any weirdness going on if Nano Banana Pro decides to actually include text back with the image that it generates. Once that's done, I'm going to go ahead and convert this response data we get here into a binary file because Gemini also gives this data back to us as a base 64 string. And so we're going to do the inverse of what we did from before. So instead of converting to JSON, we're going to convert this JSON data into a binary file by using this node. So if you open that up, you can see there's move base 64 string to file. We're going to grab our result here and set it in this data. And that is going to be our canvas and grid generated from working with Nano Banana Pro. Finally, we're going to take that resulting binary image we generated, upload that into Google Drive, and so we have that canvas as a reference saved for any other marketing activities we want to work with. Just something I like to follow when working with images, so it's all saved in one spot. Just to mention, this is the built-in Google Drive node, and it's pretty easy to set up a new credential if you just follow the steps they outline here. So make sure you do that, and then you'll be able to use that for any future Google Drive operations you have going forward. The other thing to note here is just make sure you set your file name. You pick out the folder you want to save this to, and I like to do the by URL option here, where I just copy this output folder, paste it in, and then you're going to get everything saved there that you like. So that covers it here really for step number 1, which is generating our product canvas. Moving forward, we're going to take this canvas, extract each of those images, and start upscaling them one by one so we have some HD images for the future video we're going to go ahead and create. So the first node we actually have here on this next row to generate our individual HD images is going to be a custom code block I've set up here that's going to run JavaScript code. I set up this way because it was a bit easier for me to build out an array because we're going to need to loop through each of the grid segments here, like 1, 2, 3, 4, to extract those individual images and actually upscale them. So I set this up in this code block I've set right here, and we can scroll through this to see the high level gist of what we're doing. I'm building an array here of sections that wraps to each segment of our grid, and I'm including a prompt with each of these. Basically calling it the top left section or top left quadrant. We're going to give a prompt index and then the position we're trying to extract it from. Outside of that, we're also going to break down the prompt of steps that we need to follow for extracting that individual part of the image and upscaling it. And so we're going to give some specific requirements here. So what to do, forbidden, required, and then breaking down even more constraints on our final output. So we're only going to get one of these resulting images here scaled up instead of seeing just like another canvas that gets outputted once again. This is something that's important because we can look at some of my past generations on this output image number 2, where we tried to extract and upscale an image, and we were just getting back that exact same canvas from before. And so some of this prompt may be excessive when you download this template and look at it. Just know that all of this reiteration and kind of repetitiveness here is to help steer Nano Banana Pro to avoid any flakiness that would cause you to get a canvas as output instead of one individual image that's rotated and upscaled just like this. That's the high level overview of what we're doing. And then if I scroll down to the bottom, we can see this code snippet here where we're returning our JSON output. And we're going to be giving this as an array of outputs by this sections.map function call we're making in JavaScript. This basically takes all of this section data we're building out from before, cleans it up a bit, and formats it in an array we can look at later. Let's pull this up again, and we can see that we have 4 output items here, top left, top right, bottom left, bottom right, each with their own prompt attached to it. Now that we have that set up, the next thing to do is to iterate over each of those 4 items and pass that down through this kind of pipeline I've set up here of additional node calls. So we're going to iterate over each of these 4 items, one for each quadrant of the canvas we built out. We're going to extract that image by running the prompt and calling into Nano Banana Pro once again. And we're going to get that image result back that we can download and save off to Google Drive. So that's the high level idea. Let's look again at this API call we're making in this HTTP request node into Nano Banana Pro so you can see a little bit more of what's going on. So the prompt is passed in just like from before, and we also have another inline image being provided here, but this time instead of uploading our product image, we're going to be providing our canvas image here that includes all 4 images. So we have that text prompt of which image to extract, and then we have this reference image provided here. So Nano Banana Pro knows exactly which quadrant to look at and has that image data available to extract and upscale. And so you can see here a lot of the naming and nodes we use is almost identical. We generate the image. We're going to use this exact same snippet here where we extract the first inline data result we get back from Nano Banana Pro. So this is going to give us that base 64 string representation of the image that Nano Banana Pro was extracting and upscaling. We're going to convert this to a binary file once again, so we can see that angle that was generated by Nano Banana Pro. We're going to upload that binary image to Google Drive, once again in our output folder, but giving it an image name of output image number either 1, 2, 3, or 4. And finally, we're going to set our final result here for the loop before continuing on to the next item. So 4 items go in. This logic here that's highlighted is going to get ran 4 separate times for each element on our canvas. So 1, 2, 3, 4 gets saved off to Google Drive, and then we have all of those images handy for us to proceed to the final step, which is going to be generating our video. So now that we have the product canvas generated, all 4 of our images extracted and upscaled, it's time to move on to generating our final product video that's going to rotate our e-commerce product from everything we've done from before. Just like I mentioned in the system overview, we're going to make a call into the VO 3.1 API that takes 3 of the images we've generated from before, and it takes in a text prompt that explains to VO 3.1 we want these images to be analyzed and rotated in a simple animation that's going to be featured on our e-commerce website. So let's go back here and see exactly how that is done. So after the loop finishes up, there are going to be 4 separate output items that have to be processed. We don't want to generate 4 different videos for now, so what we're going to do is make use of this aggregate node that's going to take all data that gets passed in, so those 4 images we just generated, and puts them into a list we can more easily use. And so we have image 1 in base 64, 2, 3, and 4, all at our fingertips to go forward. After that's done, I'm going to use another set field node to build out the prompt to actually generate this video for our website. This looks pretty similar to the structure we did before for, generating our canvas, but this time we're going to make it tailored toward the video. So create a smooth, seamless product showcase video of the provided e-commerce product. Pay close attention to the product dimensions and marks on the provided reference image ingredients. The scaling needs to be right so that the object we're actually showing in this video matches what the object looks like in reality. It's very important you get the hyperrealism correct here. So that's the gist of what we're doing. We're going to break down other important elements of this, like the video specifications, product and camera placement, lighting, quality, and some audio constraints here that may or may not work, especially on the audio side. So that's an important note with the VO video models for now. The audio is a little bit difficult to steer. The other points we note here is going to be with the reference images. And so we want the model to use the provided images as keyframes. That's going to show the product from different angles. So pretty simple prompt. Again, if you join our Skull community, you're going to be able to download this for yourself. Let's go on to actually generating the video. If I pull this up, we're going to see we have another HTTP request being made here to our generativelanguage.googleapis.com URL. But this time, we're going to be actually specifying VO 3.1 generates preview. And then at the end here, after the colon, we're going to use predict long running. This is just the URL you have to use when interacting with the VO3 API on Gemini. Also important to note, we're making an HTTP post request here to send off data to get generated by VO 3.1. I have the exact same authentication and credentials set up from before. And then if I scroll down to the bottom, we are going to be sending off a JSON request body to construct our request that includes both the prompt and our reference images. So I'll pull this up once again, make sure you have this set to an expression so we can dynamically pass data in. And we're going to see there's quite a bit more options being constructed here in this request. We can see up top we have this array called instances, and then after that array is done, we have these parameters we can pass in. All of this information is actually documented on the Gemini API, and so if you search for Gemini API VO 3.1 video gen, you're going to be able to see all of the parameter options you're actually able to pass in here in order to get more fine-grained control over the video. I'm covering a few of these, but if you have a specific use case or a specific shot or output format you're looking to get, make sure you review the docs here. It's like resolution, aspect ratio, reference images is one we're using to be able to pass in those reference image ingredients. Or if you want to control the first and last frame, that's another option you have too. So you have a lot of flexibility here. Highly encourage you to check out and read these docs. So going back, we're going to be using a simple video setup here where we use duration seconds set to 8. And then I'm just going to set person generation to allow adult here just to avoid any weird errors getting flagged in the Gemini API when I try and create this video. Sometimes, depending on the prompt, that can be a bit finicky or cause issues. And so I just set this as adult only just to be a bit on the safer side. Moving back to the top here, we're going to look actually what is passed in to instances. I have a prompt and I have reference images getting passed in for this video generation request. Prompt is pretty self-explanatory. We're going to take the JSON.prompt value we built out from before, and that's going to be that exact same text I covered. And then under reference images, this is where we actually pick out and provide the context in the form of images that we want to send off to the Gemini API. So it's going to be able to construct an accurate video of our product getting rotated across the different angles. So the first image I pass in is actually going to be the image we downloaded from before, actually on the Bose website. We're going to pass in the base 64 value of this because Gemini's API requires that, just to give us a good reference, kind of starting shot of the HD image. After that, we're going to pass in two separate images we generated from before that were extracted and upscaled from our canvas, ideally at different angles here. And so I'm going to look at the index of 0 and the index of 1 to get another representation of how this product looks at different angles. In essence, we're trying to give VO 3.1 as much context as possible how our product looks at different angles so we can avoid hallucinations or weird artifacts that come up as our product slowly spins around in the video we generate. VO 3.1 only supports 3 reference images at the moment, so that's why I have the 3 here. Over time, I imagine that is going to change, so be sure to look at the docs again to see what limitations come up, get removed, or what is changing there. Basically, the more context you can provide here that is of high quality, the better your output is going to be. Let's go forward to the last couple of steps here to see how we can actually get the status of our video generation, download it, and then finally save it to Google Drive. The main thing we have to do here is set up this polling loop we have in place where we wait a period of time. In this case, it's 10 seconds between each status check we do. We perform a status check by making an HTTP request to this JSON.name value we get back from the result of our original request. So we generate the video right here. We're going to get this name value back that is a identifier of the generation that is happening on Google servers. So we're going to make note of that, fetch the status using that exact same name here in a URL that looks like this. And that is going to give us some data here, whether it is done or not. If we go back to one of the earlier ones, we're going to see that we have no information being returned. But then if we look at run number 6 here, we see that we have done is equal to true, and then we have this response data that is included. That's perfect, and then that's exactly what we need to do in order to download the final video. So then we're going to do this conditional if check to see if the response is done or not. If it is done, we're going to continue forward with downloading the video and uploading it to Google Drive. If not, we're going to loop back again to this wait node, wait 10 seconds, and try again. If we jump into this conditional check, we can see we have 2 criteria here. Does JSON.response actually exist, which is going to be this object right here? And if it does exist, does the JSON.response.generate video response.generated samples actually exist as well? That is going to be the key that takes us to the URL we need to actually download our final video. So it's a bit wordy, but you're just going to be able to copy this and set it up in your own automation and get it working. So let's go back here to run number 1 here, and we can see that this branch exited false because JSON.response didn't exist. Then if I come to the last one, we can see that our branch exited true because this response data existed, and this URI right here that allows us to download the video existed as well. So let's jump forward here now to when it is true to see how we download the video. Very simple. We're going to be looking at the JSON.response once again, and so you can just drag that in right here when you're setting this up. And then that is going to make a request out to this URL that Google gave back to us, and we're going to be able to see this full video that was generated for us featuring the full rotation of our product. So this looks great. We're rotating detail like the label, the color, the shape, and size of our headphones we extracted from before. And so I would say this is a successful run. After that's done, since we got a binary file back from this, we can then save that off to Google Drive by doing a final upload operation. So file resource, upload operation, we're going to grab the data here on the left-hand side that we just downloaded, and we're going to fill out these values here to name it output video, and we're going to pass in that parent URL once again for the folder we want to save it to. So make sure you just have by URL selected there, and that's going to upload just fine no matter how big your file is. So I think that covers it here for our breakdown of this product asset generator that generates a canvas, images, and a 360-degree video featuring your product from multiple different angles. Hope that was helpful, and be sure to join our school community to get access to more videos and resources just like this.
All right, before you go, make sure to hit the like and subscribe button. Seriously, do it, because we're going to be breaking down all of the AI automations that we use to run all of our businesses. They're super helpful, and we're going to break down exactly how we do them on this YouTube channel. So make sure to like and then subscribe, and then you'll get notified when we publish new workflows that can make your businesses run 20 times more efficiently, just like we're seeing here at the recap and the other businesses that we're running. The other item is join our school community for free. The link's in the description. You'll be able to get this template, this automation that we just ran through in this video, completely for free. You can go to school and navigate to the video that you want, and then you can download the JSON output for the n8n automation. With that, you can upload it into your n8n, clone it, and then tune it for your business and your use cases. So like and subscribe, join our free community to get this automation for yourself, and we'll see you in the next video.